Okay, we're going to pick up on part 2 of this Atwood machines video. And so to remind you what we were dealing with the Fletcher's trolleys or Atwood machine, we had M1, we had a block sitting on a plane. It was going to be pulled by M2 hanging off a pulley. They gave some different coefficients of friction for sliding and kinetic. The masses were defined. And in part A, the first part of this video, we worked out and almost got to the answer of what force would be directed up the inclined plane. And so where the video ended off, the last one, was with these three numbers, which we had to add up to get what FA was. And so the calculation, putting them in your calculator, you get 0.91 newtons, and it comes up as a positive. The fact that it comes up as a positive tells you full out that it's going in the positive direction. Well, I see lots of directions here. I see down the plane, I see up the plane, I see straight down, I can see straight up. So those directions aren't the same. If you remember, though, we defined the F net as how is the pulley going, all the forces on the pulley, and the directions, therefore, are the directions that the pulley turns. Anything making the pulley turn clockwise we call positive. Since FA is a positive number, then FA is directed up the plane, and it is 0.91 newtons. Now, part B of this question reads, after the objects start to move, now they aren't standing still. Once they start moving, what's the acceleration going to be? To get an acceleration, we need to know what F net is. So in part B, it's important that we get the net force, because we know net force is the mass times acceleration. So, and that's the total mass, so it'll be both masses in this case. But we got to get F net. How are we going to get F net? Well, F net is going to be determined in much the same way we had our F net way up here. This formula for F net, meaning it's going to be the gravity of object 2, the friction because of object 1, and Fg parallel. Well, what is going to change in this question? We still have the same applied force of 0.91. We still have Fg parallel, the weight, the parallel component of the weight has not changed, nor has weight 2 changed. So all of these numbers, Fg2, Fg1 parallel, and Fa, are the same numbers as before. The only thing that changes is the mu that we had down here of 0.47 becomes 0.12, because we're at the point where the static coefficient of friction becomes the kinetic coefficient of friction. So a lot of our numbers are going to be the same that we had here. So our F net is also equal to, as we saw, Fg2 and friction and Fg1 parallel and Fa. Some of these were negatives, though. If we remember, Fg parallel was negative and Ff was negative. So to work out our F net, we needed M2G. We needed Ff from the previous video was mu M1G cos theta. Fg parallel was M1G sine theta, and Fa 0.91 newtons. So some of the numbers we're just going to draw upon what we already had. We knew that the M1G sine theta was 3.98. So that goes right here, 3.98 and 0.91. We knew that M2G was 0.595 times 9.81, so it's a 5.84. So we put our 5.84. We still have 0.91. The only number we need, that was a negative 3.98. We just need to work out this little part here in the middle. So mu is now 0.12. Mass 1, I'm going to mix them up, so I want to take a look. Mass 1 was 0.725. G was 9.81, and cosine of 34. Sorry for being sloppy there, extending it down. Bring our calculator up, so we will take 0.12, multiply by 0.725, and multiply by 9.81, and multiply by cosine of 34. Missed the enter, is 0.7076. So we'll call it 0.71, just to keep it real with everything else here. So we get 0.71, 5.89, 3.98, and 0.91. Let's toss these guys into our handy dandy calculator here. So we have 5.89 minus the previous answer, subtract 3.98 and add 0.91. Our overall force is a positive 2.11. So F net is 2.11 newtons. So we can get our acceleration now by taking to get our acceleration, we take the net force and we divide it by the mass. So 2.11 newtons is the total force now, and the mass, well, you have to realize way up here we've got two masses that are in motion and experiencing that acceleration. So both of those masses right there have to get added up. 0.725 and 0.595 we've got to work out as the total mass. 0.725 and 0.595 are our masses. Again, handy dandy calculator. So we take our 2.11, should have just kept the previous answer, insert some brackets, 0.725 and 0.595 gives us a 1.598, we'll call it 1.6 meters per second squared. Since we got a positive, again, that's an acceleration that's making the pulley turn in a clockwise direction. So there's our answer for B. Now we can try and get a start on what C is. Question C wants us to work out what is going to be the tension in the strings when the object is moving. To get the tension, this picture looks real messy, so I'm going to try and get it down here. I'm having trouble grabbing it, aren't I? There we go. You know it's a mess when. Okay. Almost ready. Now, you get to pick, when you're working on tension, you pick which of these two masses you want to work with, but you don't work with both at the same time. I think clearly mass 2 is the easier one to deal with because it seems to have less forces working on it. It's accelerating at 1.6 meters per second squared downward. It has a gravitational component downward, and tension is directed up the string. So for your F net, you really only have three forces. M1 has a friction in it, and it's got a gravitational component. We don't want to deal with that one. So for our F net formula, just with mass 2, we have to consider only mass number 2. Our F net formula is going to be Fg2 and tension, and we can solve for T. What is F net? Well, it's only, in this case, m2 times the acceleration, and that's equal to m2 times g plus tension. We're going to try and solve for T. Let's check our directions out. F net is positive, and our Fg2 is also positive. So when we take this to the other side, you'd have m2a minus m2g equals tension. We'll bring that up here. Tension is m2 onto a minus g. So we've got whatever mass 2 was, 0.595, and then we take our acceleration of 1.6 and subtract gravity, 9.81. We will work this guy out and try and quickly get at our answer. So we'll clear, and 0.595. Boys, we're having some trouble, aren't we? With our calculator. 0.595. Sorry for the low. Times 1.6 Missed the decimal. This is why I'm not going to win an Emmy for this stuff. 9.81. Clear this off, and we get a negative 4.9 newtons. Negative 4.9 newtons doesn't dismay us because it should be negative direction, counterclockwise. Tension is clearly up towards the pulley. That would be our final answer for the question, and we managed to sneak through it.